Hello, this is Mr. Stein, and in this video I'm going to go over the Mastery Items Week 10C questions. Question number 1. Multiply the following polynomials. Alright, so we take this 3 and we multiply it to each term. 3 times x is 3x, and we do the 3 times 4, which is plus 12. Letter B. We take our 2x and we multiply it to both terms in this binomial here. 2x times 4x, then 2x times minus 1. 2x times 4x is 8x squared, and 2x times minus 1 is minus 2x. Right, in letter C, we are multiplying a binomial by a binomial. So we take our x first, we multiply it to this x, then we multiply it to the 3. We get x squared plus 3x. We're finished with the first term of the first binomial. So we take our second term. Take the 1, multiply it to the x, then multiply it to the 3. We get 1x plus 3. Now we combine our like terms and simplify our answer. X squared plus 4x plus 3. Right, in letter D, we also have a binomial multiplied by a binomial. So we take the first term of our binomial, we multiply it to every term in the second binomial. 2x times 3x is 6x squared. 2x times 2 is 4x. 1 times 3x is 3x. Sorry. Then we take our 1 and we multiply it to every term here. So 1 times 3x is plus 3x, and 1 times 2 is plus 2. Then we're going to simplify our answer by combining like terms to get 6x squared plus 7x plus 2. Alright, we're going to add, subtract, multiply, or divide the following roots. Remember, we can only add or subtract roots if they have the same radicand. So that's how we determine if they're like terms. Look, this one has a radicand of 5, and this one has a radicand of 5. So we are going to deal with these coefficients. 3 subtract 5. So 3 subtract 5 is negative 2 square root 5. So 3 square root 5s subtract 5 square root 5s is negative 2 square root 5s. Then we're going to add to that 2 square root 2. And we can't simplify this anymore because these two don't have radicands that are the same. Our second one, we have 6 square root 12 divided by 3 square root 2 plus 4 square root 6. Now we need to deal with our division question first. Then we can deal with the addition. When we divide our coefficients and we divide our radicands. So we're going to get 6 divided by 3 is 2. And 12 divided by 2 is 6, 2 square root 6, plus 4 square root 6. Now we can add these together because they have the same radicand, and we get 6 square root 6. All right, in letter C, we just have a multiplication. And when we multiply our coefficients together, and we multiply our radicands together. So 5 times 2 is 10, and 2 times 8 is 16. Now the square root of 16 is an easy number that we can work with. So the square root of 16 is 4, so this becomes 10 times 4, which is then equal to 40. So we were able to completely get rid of the radical sign. In letter D, 4 square root 5 squared. Now that square applies to everything in the radical. So we get 4 square root 5 times 4 square root 5. That's going to be equal to 8. No, it's not equal to 8. 4 times 4 is not 8. 4 times 4 is 16. And 5 times 5 is 25, so it's the square root of 25. Now the square root of 25 is an easy number to work with, so it's 16 times 5, and 16 times 5 is 80. Number 3, determine if each relation is one-to-one, many to many, many to one, or one-to-one, one to many to one, or many to many. Number 3a. I start and I list out all my domain values. So I'm just doing this over here. There's just 2 and 1. Then I list my range values over here. 3 and 1. The 2 goes to the 3. The 2 goes to the 1. So it can't be one-to-one anymore, but it can be one-to-many. Then the 1 also goes to the 3, and the 1 also goes to the 1. Now, this is a one-to-many function. Because we have one item in the domain going to many items in the range. Great, now I'm confused. But it could also be a many to one, because we have many items in the domain going to one item in the range. I'm not confused anymore. See how right here we have this one item in the domain going to these 2 items in the range. That could make it one-to-many. But we also have many items in the domain going to one item in the range, which could make it many-to-one. If it's both one-to-many and many-to-one, it is many items in the domain to many items in the range. It's basically as mixed up as it can be. Letter B. A goes to 1, B goes to 2, C goes to 3, and Z goes to 26. If we just look here, we see each item in the domain once. And we see each item in the range exactly once. If you see each item in the domain exactly once and each item in the range exactly once, it's going to be a one-to-one function. As you go through chapter 5, you'll get some more experience with one-to-one, one-to-many, many-to-one relations. All right, so that's all that I have for week 10C. I hope this was helpful. If you have any questions, please put them in the comments below or contact me, and thank you for watching.